At the end of this chapter, we will work on radical addition of hydrogen halide to double bonds. From alkenes chapter, you remember, if you, for example, have this propene as an alkene, and you want to add HBr to it, then in ether, then you should have followed Markov-Nikov rule, right? Markov-Nikov to create hydrogen halide, right? This is you already learned. But what if you want a non-Markov-Nikov product? Then you can use hydrogen bromide, but you need to use UV light, or you need to use heat, or a peroxide. So by now you know that these three, UV light or heat or peroxide, whenever you have them in the reaction, they're the sign of a radical addition. So then this way you will end up having a non-Markov-Nikov product. So now you can be selective on the carbon you want the bromine to sit. The mechanism for this reaction is, again, it has 3 steps: initiation, propagation, and termination. In the initiation step, we need to generate the radicals, right? Initiation, it always includes or involves the formation of radicals. So one of the electrons through a hook, homolytic breakage, and another radical formed. 2 of these, right? Because it was symmetrical, so you have 2 of these. In the second step, then you can have HBr, right? We have the peroxide and HBr. So that's why you use peroxide or UV light and heat do the same, but you cannot show it in the mechanism. So that's why we chose the peroxide. So then again, 1 electron is needed, so hydrogen brings it with itself. So you will end up having an alcohol plus bromine radical. Okay, so this initiation step has already 2 sub-steps. Then in the propagation step, we introduce our alkene to the produced radical, right? So then radical needs 1 electron, and we can have one of the electrons of double bond. So in the third step of the reaction, we have what? Bromine will be added, and you will have this here. The reason that bromine is added to the first carbon, to the hydrogen-rich carbon, is that we will have a secondary radical. While if we had bromine here, then we would have only a primary radical. Secondary radical. So secondary is more stable than primary. Then we will have the HBr, another HBr. And then we have bromide. So in the 4th step, we will have hydrogen, bromine, plus another bromine radical. Okay? This is the new bond. I mean, I shouldn't have shown it in the wedge because it will give you the impression of having the stereochemistry. So this is the non-Markov-Nikov product. In the termination, again, we have different products. One of them is shown here for you, and more potential here. So whatever bromine radicals left will react to form bromine molecule. That's what happens in the radical reaction, addition of HX to hydrogen halide to double bond, which is the opposite of addition of hydrogen halide, like the way you used to do and you learned before. It's non-Markovnikov. The reason is because of the formation of more stable radical in the propagation step. Okay, let's work on an example. If we have this is CH3, right? So if we have just HBr by itself, we use Markovnikov reaction, right? So you have this. If you use Markovnikov reaction, no hydrogens, one hydrogen, so you have bromine here. If you use HBr in the presence of a peroxide, then you go with non-Markovnikov addition, what you just learned. Non-Markovnikov addition means you will add bromine here. That's the difference. So you can sit bromine on two different carbons. And at the end of this chapter, in this study guide, you will use the formulas for the reactions, the reactions at the end of the previous study guide, which will be provided in the exam, and try to work on the problems on the last page. Let me work on I would like to work on the second one, page 9. We are going to synthesize 2-pentanol from a hydrocarbon. 2-pentanol is this compound. 1, 2, 3, 4, 5. This is 2-pentanol. So we have different ways. Let's work with an alkene first. First 1, 2, 3, 4, 5. Let's work on the same number of carbons with an alkene. That's a very short, straightforward. If we want to have OH on this carbon and so H on this carbon, then this would be Markovnikov, right? Markovnikov. So you will need to add H. I'm sorry. Yeah, Hg, OAC2, and water, and then you need to demercurize, oxymercuration, demercuration. So it will end up giving you this cup, right? Addition of water in the form of Markovnikov reaction. You can also work with an alkyne. Then whenever you want to work with an alkyne, if you have just acetylene 2 carbons and you're going to 5 carbons, you definitely need that NH2 or NaNH2 to remove the hydrogen. Then you need to make it to a 5-carbon hydrocarbon. So you need 3 more carbons. 1, 2, 3 in the form of a primary alkyl halide, right? Because primary alkyl halide reacts and you will end up having SN2. So that's why you must have primary alkyl halide. So then you have this 2, 3, 4, and 5. The last step is to change it to OH. So you will end up having, you can add it to, if you just add water instead of alcohol, you will have either aldehyde or ketone. So let's go ahead and add sodium and NH3. So you will end up having Here, because you're adding hydrogen, the cis or trans doesn't matter, because with this reagent you will end up having trans. You can use either cis or trans because we haven't mentioned it here. And then you will work with, again, oxymercuration, demercuration, then you will have this. So that's how you work on these compounds. If we want to work on the last practice you have on page 9, number 4, prepare 2-pentanone from any organic compound, 1, 2, 3, 4, 5, 2-pentanone. So very straightforward. If you want the go from the alkene 1, 2, 3, 4, 5, then you first need to change it to, how do you change it? You can have an alkene, you can have it with, change it to alcohol and then oxidize your alcohol to a ketone, right? If you try to change it directly, there is no way. So you add H2 SO4 and water in HGS. I'm sorry, it's again HGOAC2 in water, oxymercuration, demercuration, and then to realize it better, let me change it to this. So now you need to have a Markov-Nikov addition of water, so OH is going to be added here. Now you have a secondary alcohol. What is the best way to change a secondary alcohol to a ketone? I mean, either you use a weak oxidizing agent or a strong oxidizing agent. Either way, it will give you a ketone. So that's how you need to think about these types of problems, retrosynthesis, going from the product to the reactant. Make sure you have enough practice and know the reactions well.